All right, let's do some fast talk on some random praxis questions. Um, right here, we need to focus on the fact that the semicircular region is 1/3 of the total area. That means the semicircular region is 1/2 of the remainder, right? A third here, a third here, and a third here, so it's 1/2. So we know that the the semicircle equals 1/2 of the rectangle. Well, an easier way to say that is the full circle is equal to the whole rectangle. So that's what I'm going to use because that's a little easier to think about, right? So now I just go ahead and go, oh, okay, that has a diameter d, so it has a radius of r over 2. Sorry, it has a radius of d over 2, so its area is pi d over 2 squared, right? Pi times the radius squared. And that just has area dh, right? Let's keep everything simple. All right, so we simplify here, pi d squared over 4 equals dh. And I don't like fractions, so I'm just going to simplify nicely. Pi d squared equals 4dh. And then now I'm going to pause and look at my real question. The ratio of h to d. Oh, that's pretty simple. They just want to know h over d and then just say it as h2d, right? That's the same thing. The ratio of h to d is the fraction h over d. Um, so we need h over d. Well, I guess we need to cancel out a d squared here. So we would just have plain old d left. Of course, if you cancel d squared on the right-hand side, you got to do the same thing on the left-hand side. So that all cancels. So you get pi equals 4h over d. And then I feel silly because I should have kept my 4 over there. Right, pi over 4 is h over d. So I have a ratio of pi to 4, and there's one of the answers. All right, next. For this problem, we're talking about the Richter scale. It's log 10. That means um, if you are a full unit away, you are exactly 10 times more powerful. A full unit away, so plus 1, um, the difference of 1 means 10 to the power, 10 to that power times stronger. Difference of 1, 10 to that power times stronger. Okay, let me scribble that down. Difference 1, that implies that it is 10 to that power times stronger. Well, just generalize that. That's for things that are an integer apart, 10 to the first. If they're different by anything, like 0.2, if they differ by 0.2, then that implies that they are 10 to the power 0.2 times stronger. There is a way to go ahead and solve this with logarithms, but I prefer to just go the intuitive way. Now all I have to do is punch this into my calculator. Um, I don't actually know the answer right off the top of my head, and I'm not going to spend the time punching that into my calculator, but it's probably one of these two. I wish I intuitively knew which. I don't. The answer will be 1.2 or 1.58. Don't know which, you figure it out by punching into your calculator. Just generally the idea. It's 10 to the power times stronger. That's what log scale means. A difference of one is not, you know, one times stronger or doubling or what, right? A difference of one is 10 times stronger. Difference of x, 10 to the x times stronger. Difference of 0.2, great. 10 to the power 0.2 times stronger. Convert that to a percentage. Next, six-sided cube, probabilities 2, 3, 4, 5, 6 are equal. Probability of 1 is twice as the 2. All right, let's just be very intuitive here, right? 1 has 2 chances, and the other 5 each have 1 chance. That means there's 7 total chances. So throwing a 1 is going to be 2 out of 7, and all of the rest are going to be 1 out of 7 each. Right, there's 5 of them. And so those add up to 5/7, and the 1 is 2/7. If they were doing things in a more complex manner, like they threw in, 6 isn't on that list, there's only 4 of them, and 6 is 3 times the probability of 1, then I would recommend you start assigning a variable. Keep it simple. Let x be 2, 3, 4, 5, and then, 1 is a 2x, and 6 is a 3 times 2x, and then you would just do the algebra, and remember, this is the way you solve things. The total probability is always 1, right? So not, right, you add them all up, set it equal to 1, you can solve the variable. If the number cube is thrown twice, what is the probability that the sum of the numbers thrown will be 4? Well, that's a 1 plus 3. That's a 2 plus 2. And also it could be 3 plus 1. The chance of 1 and 3 is 2/7, right? 2/7 for the 1, and, right? And means multiply. And 1/7 for the 3. And the 2's are 1/7 each. All right, we're rolling twice, something with 7ths, so of course the answer is going to be out of 49ths. And the 3 and the 1, well, that's the 1/7 times the 2/7, right? The 1 is weighted to show up a little more often than we expect. So it looks like we get, right, 49ths, obviously. And we have 2 plus 1 plus 2. So that's 5/49ths. All right, new problem. And what's going on here? This is a very awkwardly phrased story problem, but if you draw a diagram, you're probably going to be fine. The other way to do it would be to plot dots on a graph. Basically, all you need to know is point slope concepts. So let's see. At noon, that's probably going to be 0, right? Leak for 6 hours. At 6 p.m., 1/4 of the volume of the water is left. The volume in the tank is 1/4 of the volume that we started with. That means we lost 3/4 of the tank. We lost 3/4 of the tank in 6 hours. Well, I can easily make that into the fraction lost 3/24 of a tank each hour. And now I'll be a little more careful, right? Of a tank, lost 3/4 of a tank each hour, right? That's a slope. That's how much I'm changing. And of course, I start with one tank. All right. So I have this slope intercept going on in my mind. I know I start with, and at time zero, I have one tank, and there's my intercept, and my slope is 3/4 of a tank per hour. So I feel like I could do a point slope formula for this instantly. The only thing you have to realize is that G is what we need to use to represent the full tank, right? H is going to be the function. So the function H varies with time, right? T is our variable. And we want to have that idea of, all right, we start with one tank. So we start with G gallons. And every hour, right, each hour, so there's the number of hours, each hour we lose 3/24 of a tank. Oh, I hope you don't mind if I reduce that to 1/8. Now I've got H and G and T all related to each other. I'm just a little puzzled why they didn't just give us this, because they want, right? Clearly they want the height of the water as a function of time, but for some reason they don't write it that way. They have a very weird looking formula with, I guess it makes a tiny bit of sense because H and T are the variables. I guess they're doing some kind of general form where you have H and T as your two variables. It's like, 7x plus 9y equals whatever. It just looks a little confusing. So, of course, if they want H and T on the same side, we give them that, right? And it looks like they all start with H, so I'll start with H. H plus T over 8 equals G, right? That's how I'm going to get there. I'm going to aim at the right format, H on the left, T on the right, and then just the amount of G on the, what I meant is T on the right part of the left, and then just the constant gallons in the full tank on the right-hand side of the equation. Still doesn't match. So, of course, none of these have fractions. So obviously you got to multiply by 8. 8H plus T equals 8G. And there we go, right? We've found the answer. 8H plus, oops. What did I miss? Oh, I'm sorry. Let's back up. I'll show it in red. I don't lose 1/8 of a gallon. I don't lose 1/8 of a gallon per hour. I lose 1/8 of a tank each hour. So I lost my G over here. Sorry about that. So there should be an extra G over here. So that means there's a G over here. I'll put it on the other side of the T now. And that means there's a G over here. So this one is indeed the answer. Sorry about that. And that's almost authentic, right? You miss something, you're almost the same as the answer. If you're in a rush, then you just pick this one and mark it to come back. I needed to pretend I'd picked that one, marked it, bookmarked it, and then come around again and recheck my algebra. Unless you know you're very good at checking mixed up algebra. Most people aren't. What is the value of this? This is a limit as theta goes to 0 of a fraction. So the first thing that comes to my mind is L'Hopital's rule. So I'm looking for the 0 over 0 or infinity over infinity. So when I take the limit, what do I get? The tangent of put in 0 is 0. And let's see, the cosine of 4 theta, the cosine of 4 theta, that's the cosine of 0, so that's a 1, but we have 3, 0 in front. We have 3, theta in front, so that's 3 times 0 times 1 on the bottom. So yep, we get 0 over 0 as expected. So we have to go ahead and apply L'Hopital, right? We apply L'Hopital when we get these indefinite forms. So let's do it. The derivative of the top, well, hopefully you've memorized it. If you haven't, hopefully you've memorized the derivative of sine and cosine. And then you can do product rule, quotient rule, whatever, to take the derivative of tangent. Turns out to be secant squared. So the answer here is secant squared of 2 theta. But let me remind you, the derivative is respect to theta, so you need a chain term. You got to multiply by 2 at the end here. And then the bottom is a giant pain because it's a product. So remember, you have to apply the product rule here. So let's do 3 theta. Let's leave that alone and multiply it by the derivative of cosine of 4 theta. Well, derivative of cosine is negative sine. Of course, you just copy 4 theta, the thing you are evaluating, but you realize, oops, that's not plain old theta, so we get a 4 for a chain term. That was first derivative second. And then, of course, the other part is second derivative first. So now I just copy the cosine of 4 theta. There it is. And multiply it by the derivative of 3 theta. And oh, that's nice. That's just 3. But now I have to evaluate at 0 again, right? Evaluate it at 0. Secant squared of 2 theta, that's secant squared of 0. That's the same as 1 over cosine squared of 0. Oh, that's fine. Cosine of 0 is 1, and 1 squared is 1, and 1 over 1 is 1. So the top is just 2, right? After I take the limit, I get 2 for the top. What do I get for the bottom? Well, that's going to 0. That's multiplication. This whole term drops out to nothing. And then I get the cosine, oh, the cosine of 0, which is 1, right, times 3, of course, times 3. So the bottom, first term dropped out, second term is a 3. So there's the answer. The 2/3 is the answer. All right. Something completely new. Oh, this one is a little crazy. Um, this one might be a do later or a do never. Um, Let me try to help you like reason through it, right? Always draw a diagram, right? Always draw a diagram. Um, so here we go. We know x cubed, it's that rapidly changing thing. It gets flat and then it goes up rapidly, okay? What we're looking for is the idea that the line through the origin, right, is also the tangent line. So I'm just going to draw a rough approximation, right? That's what I want, right? I want the blue line, which is the one through the origin, to be the same as the red line, which, is the tangent, right? I'm looking for the purple line, where the tangent line and the line is the line through the origin. Okay, how do I deal with that? Well, look, let's just pick a point, pick the point, and then just call the x value a and solve for a. See if we can do that. If we can do that, then we're done, because if we know a, we also know the point, right? This is the point a, comma, you're on the function, so all you are is a cubed plus 16, right? That's simple enough. But think about this. This line through the origin is also a tangent line. And remember, we can find the slopes of tangent lines fairly easily, right? We take the derivative, use your polynomial rule, you get 3x squared. The derivative of a constant is 0, right? So we know the derivative. right? We know y prime is 3x squared. The slope of that blue and red tangent line is 3x squared. But the x value is a, so I can say, hey, the slope is 3a squared. All right? So you're like, so what? Well, so now I have a point and a slope, right? Whenever I have a point and a slope, I can write down the equation of the line and then I just got to adjust things so I know the equation goes through 0, 0. Let's deal with that later. Let's just get the equation, right? Simple, right? Y minus the y value. Okay, maybe not so simple, uh, but not. Okay, let's say simple, but you got to be meticulous, right? There's a lot of parentheses going on, right? The equation of that blue and red line, y minus the y value, yep, y minus the y value equals the slope, okay? Tangent line is got the derivative for the slope, 3x squared, evaluated at a, all right? There's the slope, depends on the x value, 3a squared, x is a, right? Times x minus the x value, x minus the x value. All right, so there it is. I just use the x value, right? And I use the slope and I use the y value point slope formula. Whew. Well, let's try it, right? Now we get clever. Now we're like, oh, let's get it into slope intercept form, right? Y equals mx plus b. But guess what? We need b equals 0, right? Because the intercept is at the origin. We have to get y equals mx, right? There can't be any intercept. The intercept has to be 0. Okay, fine. Solve for y. You get, all right, let's do a little distribution here. 3a squared x minus 3a cubed. All right, I'm going to add the a cubed plus 16 to both sides, right? I'm going to add it to both sides. So plus a cubed plus 16. So it looks like I have 3a squared as my slope. All right, that's times x. And then my constant term is, it looks a little nutty at first, but then I go, oh, minus 3a cubed plus a cubed. That's great. Minus 2a cubed plus 16. Okay. But remember, that has to be 0, right? Otherwise, right, that is the equation through any arbitrary point with x value a, the y value pops out, the derivative gives you the slope, so you've found the equation of every tangent line. You want to find the particular value of a that makes the tangent line also go through the origin. So that means the y-intercept has to be 0. So negative 2a cubed plus 16 equals 0, right? I'll let you, finish off the algebra. You know, what you get is a cubed equals 8, right? You can see the division by 2 after you move one of the terms. Division by negative 2, doesn't matter. You get 8 equals 3. Sorry, a. I don't know why I said that. A equals 2. Okay, great. A equals 2 is the answer. Nope. What is the slope of the line, right? So the answer is not a equals 2. The answer turns into 3 times 2 squared, and that's 3 times 4. That's 12. That's the actual answer. All right, last of the random praxis items. Okay, this one looks insane at first because there's so much language going on. So you skim through it, and then after a while, you realize that it's just telling you that, yes, this is a compound interest problem, a very normal compound interest problem, and it makes sense to use that equation, right? That's it. So this is a matter of it's easy in disguise with lots of words, but the words are telling you that, what was obvious from the very beginning, continuous interest is true. So, right, I'm a little concerned. So I'm like, yikes, what? How do what am I supposed to do? I'm right. Ag, right. Well, look, you got two variables, so don't panic, right? You got variable P0, right? That's the initial money. That's actually what they want, the amount the investor deposited in time zero. That is P0. They want P0. It's one of the variables, right? And the other variable is the R. They didn't actually tell you what R is. So you have two variables. It feels terrifying for a moment because how can the interest rate be a variable? Oh my goodness, they always tell it to me. Hang on. You know algebra, right? You have two variables. You need to find two equations. And guess what? They gave you 2 points. So make an equation out of 1 point and make an equation out of the other point. And now you'll have two equations and 2 points. And hopefully, if you remain calm, you'll figure out how to deal with that algebra, right? At the very worst, you can solve for one variable in one equation, substitute it into the other, see what happens. It should work out, right? Not guaranteed, but the feeling of two equations and two unknowns is good. All right, so let's get these two equations, right? Let's get the green equation. That means P of 2, P of 3 is the amount of money. So P of 3 is $2,000. The value of P is $2,000 after uh, 3 years. So that's P0. I could call it the initial investment. I'll just call it P0 because that's what I'm looking at. E to the, let's see, 3 years, the T is 3. I'll write it as 3R, right? It's really R times 3, time is 3, but I'll write it as 3R because that's the way we conventionally write things. That's it, right? The other one is exactly the same, right? The p-value is, right, the vertical value is 5,000 when the horizontal value is 5. 5, no, 8, sorry. P0 e to the 8R. So I do have a moment of panic because I'm like, how in the world am I going to solve this? Right? Well, remember, two variables, two unknowns. Do what you want. Eliminate. You could solve for P0 and substitute it in and get the R. Um, you could solve for R in one equation, substitute it in, and get the P0, right? They want the P0. Remember, that was the question. So it looks like I ought to solve one of these equations for R and substitute it into the other. I actually don't want to do that because I know to solve for an R up in an exponent, you gotta, right, take logs. I don't want to do that. So I'm gonna try, I'll try to be a little sneaky. I'll try to, like, I don't know, make things work out. I'm not sure I can, but I'll try. Uh, can I do anything sneaky here? Um, can I multiply by e to the 5r on both sides of that one? Right? There's the e to the 5r. And then, right, e to the 3r times e to the 5r is e to the 8r, right? So both sides are P0 e to the 8r, P0 e to the 8r. Great. So both sides are equal. So that looks nice, right? That's e to the 5r times 2,000 equals 5,000. That's kind of good. Uh, Still kind of looks like I can't quite uh, get away with not logs. So I'll just cave in, right? Divide by 2,000. What do we got here? E to the 5r equals 2.5. Oh, and suddenly I realize, wait, if I just took the bottom equation divided by the top, that would have been, 5,000 divided by 2,000, and then P0 e to the 8r divided by e to the 3r, the P0s cancel. 8r minus 3r is 5r. So I tried to sneak around. All I could do is get this messy equation. So it does look like I've got to take natural logs no matter what, right? Take the natural log of both sides. I'm going to write it out even though I shouldn't. The natural log of the exponential, you should know it cancels out. ln of 2.5, okay, that's calculator work. It's just an ugly number, right? And that's just 5r. Right? So, I'll do this the fast way. I'll divide by 5. So what do we have? Not quite the answer because we found the R value. But remember, P0 is the amount of money you have at time 0. So we really want to find, right? We want to find P evaluated at time 0. So what we want is, the answer is that, oh, why am I going to the original? That's just a circular definition. We want to find P0. We found R. What do you do when you have two equations and two unknowns and you've solved for one variable? You go back to the other variable and you plug it in. Doesn't matter. You go back to the original system of equations, you plug in e to the power, you plug in the R, and then you solve for the other variable. So that's all I'm going to do. I'm going to drive back up here. Let's put it in the yellow one just because it's a little cleaner. That's the value of R, and it looks like a terrible mess, but it's actually better than you think, right? 5,000 equals P0, right? That's the thing I'm looking for. E to the power, right? I want 8R. So let's do a little work here. I want 8R. So I want 8/5 of ln 2.5. I'm going to rewrite that, and you'll see why in just a moment. I want to think of that as ln of 2.5, right? Times 8/5, right? E to the ln of 2.5 times 8/5. Oh, by the way, if you're a calculator junkie, you're not doing any of this. You just figured out the value of R as a number, right? R is ln 2.5 over 5. Type, 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 type. You get an ugly decimal for R. You multiply by 8. You take e to that power. And oh yeah, you take 5,000 divided by that number to solve P0. If you like arithmetic and algebra better, well, look what I did. I got an e to the ln term here. So I get 5,000 equals P0, 5/2, sorry, 2.5, right? But that's still to the power 8/5, right? Now I'm the one that has to pull out the calculator. There's no way to get out of, figuring out what this is. That's 2.5 to the power 1.6, right? And that's P0 times that number, right? P0 times that number is equal to 5,000 over here. So to solve for P0, I'm just going to take that number, divide over there. Calculator work. Nothing pretty about this one, except maybe the green and yellow equations up top. I don't know of any elegant way to get to P0 nicely, simply because when you've got a variable stuck up inside an exponential term, logarithms are going to come down on your head. That's all you can do, right? There's not really much else you can do, um, but deal with the logarithms. Yes, I could have done the calculator before I did that red substitution. That's fine. If you want to reach for your calculator, there is nothing wrong with writing down the yellow equation. 5,000 equals P0 e to the power 8 times, and then you get that nasty looking number that you computed on your calculator earlier, right? E to the 8 times that is going to be some number, also nasty looking. 5,000 equals P0 times a nasty number. Fine, P0 is 5,000 divided by that nasty number, right? It just turns out that the nasty number doesn't look quite as terrible as you thought. You know, it came from something nice, semi-nice, but it is itself a nasty number no matter what. All right, that's all we've got time for.